Hi everyone, my name is Waleed and I'm a civil engineer. So in today's video we're going to see what is basically 1D hydraulics, and then you maybe heard of 2D hydraulics. 2D hydraulics, and there is also 1D 2D coupled model. So what are the differences between these and how we use these hydraulic methods um, in civil engineering or water engineering? So basically, 1D is about the flow within the drainage channel. So 1D is in drainage channel. Any channel it can be a water course, it can be a pipe, it can be a ditch. So this is all in called as 1D analysis. For example, you have a pipe network. Let's say this is a pipe, or um, just a pipe. You have one pipe and then you will have the manhole. uh, I can not very good in the drawing. So for example, we have a manhole, and then we have a, for example, pipe, and then going to downstream, and then we have another manhole, and we can say that this is something the ground level. So underground pipe network is basically known as the water will be flowing from in one dimensional, like it will be only going this way and then this way. So this is called 1D. And even if you have, for example, a river channel, and the water is flowing, it is also a 1D, and this is also an example of 1D. So what is then 2D? So we have understand the 1D, and then what is 2D hydraulics? 2D is basically, let's take an example of a surface. Let's say this is a surface, a ground, a a park, or any ground surface, and then we can say that we have water drops that goes onto the surface, and after it drops on the ground, how it moves, like it moves like this. And also you can see the small squares, consider it as a grade. So it go wherever the slope will be, and water will go that way. So this is basically to understand what is the flood plain is, to understand in case of flooding how the water will flow. And the pipe network, and mostly drainage ditches, we usually do in land development to see the residential development or after development how the water will flow. And then it comes as 1D 2D network. So basically 1D 2D network means you have a manhole, and then you have a manhole and the water pipe, and it connects like this. And for example, the water is surcharged and there is flood risk, and once it is overflowing, starts to overflow the water, then how it will act on the ground. Because currently if we have 1D model, we will have a table that will show that the, for example, MH1. So MH1 has the flooding, but how that flooding will occur on the ground. So this is why we need a 1D 2D network. So basically this is for the more detailed analysis. And this analysis, like 2D analysis, this is also known as direct rainfall, uh, and it is also known as direct rainfall, and also rain on grid model. So if you heard of these terms in your articles or journal articles, basically these are used in research. So mostly researches are done on these models. For example, how there will be risk of flooding, and maybe if you have heard of the software name HackRAS. So HackRAS is basically rain on grid model. And direct rainfall, it only shows you like if there is a floodplain and how we can do. I also have a bit of presentation here, so I hope this clears some of these basic terminologies for you. Well, I also have this detailed presentation here, where we can see The basic definition. So 1D is a one-dimensional flow, and then 2D is two-dimensional flow. Obviously, the basic understanding of this one. And the common example you can see, this is a river cross section. So we have cross section 1, cross section 2, cross section 3, and we can see the flow direction is one way from upstream to downstream. And this will basically used to know the water level, to see the flow rate, flow velocity, and then the cross sectional area we usually have, and also the hydraulic head and flood level, or the what we say that we have how much difference between the head and the exceedance level, so to control the flooding in the river, so we need these to calculate all of these. And the 2D is basically in two-dimensional. As I mentioned, for example, water drop onto your surface, like this is your surface, and how it feels like, which direction water will go. And for this one we usually use uh, Hackross. Maybe you have heard of this one. And this can also be done in InfoWorks, ICM. Uh, and this one basically one dimensional, or we do usually do in info drainage, and previously uh, maybe storm and sanitary analysis by Civil 3D. So these are basically we do for the new land developments. We need to analyze what will be the risk of flooding, what will be the capacity of our pipe network. So we basically use this model in info drainage. These are basically 2D for the floodplain, and this so the examples are rivers, channels, culverts, pipe, anything, and these are the examples like on the ground. So now what we have for is coupled network. So 1D 2D coupled network is basically combines the both the approach. So for 1D 2D network, we have to analyze in more powerful tools. Info drainage can do that one. We will see in some examples, but mostly for citywide catchments, InfoWorks, InfoWork will works the best. InfoWorks, ICM. So this is basically 1D 2D analysis, and you can even find the journal articles from Chinese researchers. They also have done a lot of research on this one, so that if you have time to read those, quite nice. So in this example, you can see what is so now you have this one. So let's see if you can figure out what is 1D and what is 2D. As you can see, this plain area, like this field, is in 2D region, and the river flowing, we can see this one is 1D. You can see a culvert or a bridge or anything that takes the water in one direction, also 1D. And now, for example, if we have to see like water in the river is at a certain level that it risk of flooding on the 2D ground. So this will be 1D, 2D. So from 1D to 2D, for example, water flows so high that it will be a flooding on the nearby buildings, nearby planes, how it will react. So this for these purposes we need 1D, 2D model. So you can see the river is a 1D, we have 2D floodplain, and then we have a floodplain to river. For example, the rain drops onto the floodplain and the water goes into the river, and how it will increase the water level in this river. So this will also be known from the 1D 2D coupled model. So there are two things. I can give you the example here. So practical example we have here, 1D river channel is a 1D, the bridge or culvert is a 1D. The town we can see here is, and the fields and the houses is town and surrounding is 2D. Now what is 1D 2D here? It will be the river banks. You can see these banks. like water will go above these banks or the water will come into these banks into the river. So how this will be act, it will be known from 1D and 2D. So and how this is useful, and this is basically mostly cities they get investing a lot to understand 1D 2D analysis. So this 1D 2D analysis give us much better representation of the modeling, how water will be looks like in future, or the in case of high storm events. So this is 1D 2D is coupled model is better than 1D or simply 2D model. So, about the InfoWorks ICM, as I mentioned earlier, how we can use is this will, for example, flow along a defined path is basically rivers, pipes, and channels, and flow across a 2D, across an area where you have like X and Y axis, two axis area. So floodplains, roads, fields. This can be 1D. This can be 2D model. And how about the 1D 2D coupled model? So coupled model will be the network plus the spreading across the land. For example, urban flooding model and riverside, as I mentioned, there are a lot of research going on different cities. They are going all towards the digital. Now this is a key to remember. So for 1D, where does the water flow along the channel? And for example, you have a pipe, a river, or channel. So this can be where does the water flow along the channel. And then for the 2D, it's easy to remember where does the water go across the land. So how the water will go is a grid, this side, this angle, where the water will go. So this will tell us about the 2D. And 1D, 2D will be what happens when the channel and the surrounding land interact. So this is the interaction between the land and the river, or even, for example, it's not about the river. It's anything can be. For example, you have a manhole, as I mentioned, and then it has a flooding, and how it will go along the on your surface, how it will go on which side, which property will be as a risk of high flooding. So this is basically to understand about the 1D model or 2D model, and then 1D 2D modeling. And so and if you have heard about the HECRAS, that's basically the 2D model. That's basically for the direct rainfall. As I mentioned, key terms basically used in the industry: direct rainfall. This is entirely 2D, and rain on grid. The I will show you how we can do the 2D modeling and the direct rainfall model into the InfoWorks ICM. But this is basically the basic terminologies. Maybe you have heard a lot of time, you came across a lot of time, but didn't know like what are these, or how are these useful in day-to-day life. So 1D basically for the land developers, they usually do the 1D analysis, pipe network, they have swales, they have pond to see the flooding, 1 in 100 year flooding, 1 in 30 year, 1 in 100 year. If they have flooding or not, they if it's not flooding, the model is working fine. 1D model. We don't do 1D, 2D quite a lot. It's basically at a bigger scale, at a citywide scale. You need a lot of investments. But a small 1D 2D analysis I will also show you in the info drainage, like how you can do in info drainage a small catchments. But this is the basic terms. Hope you guys understand this concept better now. If you guys have any questions, please ask in the comment section. Thank you for watching.